Vishnu, you are telling something.
Yes, sir. We saw about forging defects. And,
Yeah, yeah, yeah. Okay, fine. So we have discussed yesterday about the forging defects, what are the possible defects we are getting while we are doing the forging process, right? Then we talked about the new technique, what we are basically we are doing now when we are working with forging process. For example, the powder metallurgy forging. Okay, so that means we are putting the powder instead of the billet or the sheet, whatever we are doing in the traditional process. Then finally, we have talked about the residual stresses. Okay, what are the residual stresses? How actually it is forming or how it is creating. Okay, and some kind of residual stress. Of course, we have covered in the beginning how we are removing this one with the help of the heat treatment, but also the the heating rate, the cooling cycle, and the holding time. And these are all. And what are the contaminants also? For example, if it will reactive oxidize something, probably it is also happening in that case. So these are all we have covered, and only small portion is remain. A small derivation we will do today, and also one numerical I have prepared. Maybe if we will prepare, we will solve that numerical. Then probably we can do other numerical as well. Okay, small derivation. So just you can go maybe 2-3 slides we have today. Okay, so just you can think carefully. Okay, so here we will talk about today the forging in plane strain. Okay, so when we are doing any kind of, because only every time we are thinking about the process, how we are manufacturing, because when we are especially we are talking about manufacturing, we are talking how the raw material we are putting and how the process is happening. But at the same time also as we are the technical person, we have to understand the application part. Of course, we are doing in the the exam, the higher order thinking, if this kind of material you have, or maybe this kind of shape you have, how you are preparing. Maybe this time also I will do this kind of, because every time we are now giving the numerical. So we will do one thing, maybe two numerical we will prepare, then one I will give higher order thinking. For example, if I will give a shape, so you can tell that in which process maybe you can make it like this. Okay. So here also we have to think a little application side when we are doing any forging or any rolling. So how the application or how the process actually it is going, because you are only thinking the raw material, then this is the outcome. So here we have taken the figure shows the stresses in the forging of a plate of constant thickness under conditions of the plane strain. So how we are telling the plane strain? Because you have the zero strain in the directional normal to the axis of applied tensile stress and direction of the crack growth. Okay, so we have to assume something, because if you will not assume, then you cannot do the derivation. So if you will see the schematic diagram here, you can see the stresses acting on a plate, force in plane strain. Okay, so if you have the die here, the upper die, the upper portion, and this is the lower die, and you have the material here. Okay, so this is the zone we have. We are making the forging. Here you are applying the force or the pressure, right? And the same time also you are applying the pressure here, whether this is constant in the or maybe this is fixed, or whether this is moving. Okay, so normally we are considering here the fixed one, but still you have some pressure here. Okay, in the both the side. And this area is the the small portion when we are talking. See, this is x, or for example this is talking as a dx, and the strain you have generating here whenever you are pressing, you have some strain. But at the latter moment also we'll talk about the friction instead of the strain, also what kind of friction you are getting or you are generating here. And the moment you have the stress you are applying here or you are getting here, if this is sigma x, so then you will find in the opposite direction also you will find sigma x plus a d delta x, because this is dx, right? So here I mentioned taking the equilibrium of the forces in the x direction. If you will see in the x direction, if you want to, for example, if you will remember your engineering mechanics, okay, what you have studied there. If it is in equilibrium condition in x direction, so you will find this kind of forces here, right? So one is sigma x into h, because you have the height here, and this is the thickness, and the thickness is h, and this area. Okay, so you can imagine the here every time in the numerical you will be confused. This is the area, or maybe this is the length. Okay, and this length is 2a. Well, this is a half portion, and this is another half portion. So we have considered this is 2a, right? So here if you will see the equilibrium forces, if you will take sigma x into h minus, because this is in opposite direction, sigma x plus d delta x into h minus, and what is the strain generating here? 2 tau xy dx equal to 0. Is it fine, this equation? The first equation. Yeah.
Yes, sir.
Okay. So if this is clear, this first equation, then from this equation, can you derive this one? D del sigma x by dx equal to minus 2 tau xy by h. You have to just move this one to right hand side, or maybe left hand side. This total part you can move to the right hand side. Okay, maybe I removed actually another 2-3 step. Directly I put here. Okay, what you will do in the left hand side, whatever the h value you have, okay, or maybe this h you can divide here, minus 2 tau xy dx by h. Okay, and this portion will go to the right hand side, sigma x h minus delta x plus d delta x. Okay, because you have to open the bracket here. If you will not open the bracket, then you cannot find. You have to open the bracket, then move the total side to the right hand side. Is it okay?
Yes, sir.
Yeah, okay. Yeah, other student, are you getting this one? Maybe you have to open the bracket, otherwise you cannot do it. Okay, so you can at least try. What you will do, the minus 2 tau xy dx, you can keep in the left hand side. Take the total value. For example, delta x h minus delta x plus d delta x into h, you can take to the right hand side. The moment you will take it right hand side, okay, then you have to open the bracket, the delta x into h, okay, plus delta d delta x into h, and h you will make it common, because if you will make it common, then this h you can divide here, minus 2 tau xy by d and xy dx by h. Okay, then two things will be cancelled. The moment two things it will be cancelled, then you will find d delta x by dx. Okay.
Yes, sir.
Okay, fine. So if these two statements or the two equations are clear, now whatever the von Mises yield criteria we have discussed earlier, maybe in module 1. So this sigma 1 minus sigma 3 equal to 2 by root over 3 sigma 0. Okay, so this equation already we have derived in module 1. Okay, just you can cross check. Okay, equal to, here we have mentioned sigma 0 prime. Okay, or maybe sometimes we are writing this is YF bar. Okay, the mean flow stress. Right, this term. Okay, you can just write this equation, and when you have free time, you can just open your module 1. You will find this von Mises criteria we have already discussed. Okay, and the sigma 0 dash or the sigma 0 prime is known as the mean flow stress or yield strength of the material. Fine. You can just write this equation. I think in the next page also we need that one.
Sir,
Yeah.
what is that h, sir?
H is this one, this height. You
Oh,
can
okay.
see here.
Yeah,
Okay.
yeah, yes, sir.
Yeah, so you have to remember one is h here we need, okay, and one is, because whenever this billet you have, one is length, and the length is 2a, okay, this a and this a, 2a, and this is height, and one you will find width also, because this is a, like, the rectangle sheet. So width also you will find. If you remember in machining also what we have done, the thickness you have, so this is normally h, and the length normally we have 2a, and width also w, small w will come later. Okay.
Okay, sir.
Okay, fine. Is it clear? All the three equations? Yeah. So if these three equations is clear, again, just I wrote here the von Mises yield criteria. Okay, the same equation I just put here. And this equation actually from where we have taken, and this equation we have taken from the von Mises yield criteria. The sigma 0 equal to 1 by root 2, sigma 1 minus sigma 2 square plus sigma 2 minus sigma 3 square plus sigma 3 minus sigma square to the power 0.5 or root over. Okay, this equation also we have derived. Just I mentioned as a recap. Okay.
Okay, sir.
Okay, sir.
Okay. So now if we have, because you have to assume now something, if we define the P, whatever the pressure we are applying here, and the sigma x, if the positive compressive stress, if you have, then you will find the sigma 1 minus sigma 3 equal to YF bar or the sigma 0 dash. Okay, and also if this is a positive, because one is in the positive side, okay, and this one is the opposing, the sigma s is opposing you, that means opposing the pressure, so you will find P minus sigma x. Okay.
Okay.
Okay, so if now whatever the YF bar you have or the sigma 0 prime if you have, if this is doesn't change with x, okay, whatever the small value or the in x direction, whatever the small area or the small distance what you are taking, if this is not changed, so can you write dp by dx equal to d sigma x by dx? Because p equal to sigma x now.
Yes, sir.
Okay, so just we are taking the derivative dp by dx equal to d sigma x by dx. Okay, so if from this equation, if it is clear, so can you write now dp by dx equal to minus 2 tau xy by h?
Yes, sir.
Okay, because earlier we have derived this one.
Yes, sir.
Okay. Yeah, other students, are you getting?
Yes, sir.
Okay, so if this equation is clear, if the shearing stress is related to the normal pressure, so that means we have this equation we have already known from the Coulomb's law of sliding friction, tau xy equal to mu into p, and where this mu instead of this tau xy, now we are considering as this is friction. Okay, so if you know this equation, or this is the assumption, if you are taking tau xy equal to mu p, so can you put this value and can you get this value dp by p equal to minus 2 mu by h into dx? Just you can put this equation here.
Yes, sir.
Okay,
We can get it, sir.
yeah. So where it is known that the p is equal to the forging pressure and mu equal to the friction or the sliding friction. Okay, just we have taken instead of the tau xy, we have just converted to mu.
Fine, sir.
Yeah, okay. So then the next page, you can see just now, like, all the equations are, you can put somewhere like, 1, 2, 3, 4. If you'll put 1, 3, 4, now you have to integrate both the sides. If you'll integrate, you will find ln p equal to minus, if you'll go back to this one, ln p equal to, because you have this equation, dp by p equal to minus 2 mu by h dx. Okay, so if you'll integrate both the side, you will find ln p equal to minus 2 mu x by h plus ln c. Okay, c is the constant.
Okay, sir.
Okay, so here is the C, actually we have some value, because sometimes, like, in the numerical, if this value is not given, so we have to consider that, for example, 1.2 to 2.5 for the offsetting a cylinder between the flat dies. If this is 3 to 8 for simple closed die forging, if 8 to 12, this is more complex shapes. Okay, this is the common value we have for the AC. Okay, so now if this equation is clear, the constant of integration C is evaluated by the boundary conditions. Okay, so here also we are assuming if x equal to a and the lateral stress sigma x equal to 0. Initially, if you remember that I mentioned, the if we are talking about the plane strain, that means the strain and everything will be 0 in the beginning. So from this equation, can you derive ln c equal to ln sigma 0 prime plus 2 mu a by h? Okay, so instead of x, we are now converting to a, because our this length we have considering a, not the x, because x we are taking about for 1 unit length, but now we are considering the total whole length. Right?
Fine, sir.
Okay, so if this equation is clear, so then can you make it p equal to sigma 0 prime exponential 2 mu by h into a minus x?
Yes, sir.
You are doing or just only telling? Doing?
Doing, sir.
Okay, okay. Is it clear? Okay, so if this equation is clear, so now just only this is converted to p equal to sigma 0 prime 1 plus 2 mu into a minus x by h. Okay, and the mean forging force, if this is the forging force P, okay, and if you want to find out mean forging force, and mean forging force P bar equal to integration 0 to a, because you are considering now the length a, okay, not considering x, because x was the for unit length. So now you are converting to that particular length, okay, and P dx by a equal to, you will find this equation. Okay, and this minus, please think this one, do not make this minus near to 2 mu a by h. And this minus is after you are getting the whole value here, e to the power 2 mu a by h, then this is from that value you have to make minus 1, not from here on the top. Okay.
Okay, sir.
Okay, so now two things you got only. One is the forging pressure, then one is the average forging pressure or the mean forging pressure. So now one more thing, you have the total forging load, okay, P, and this P you can make it P bar into 2A into W. Why you are telling total forging? Because you have initially you have considered for X, then you have considered for A. Okay, so now we are considering total load. So total load is for 2A, not for the small part, half part. This is for 2A. Right? So whatever the total or the average forging force you have or forging pressure you have into the 2A and whatever the width you have into W. Okay, and where W is known as the width. So you will find this equation. Okay, so three things. Initially, we have converted for X because X is the unit length, a small area we are considering. Then we have considered the half or the A. Then we have considered for the total load. That means total 2A. Fine.
Fine, sir. Sir, can you show
Yes,
the
sir.
diagram?
Yeah. Okay, so initially we have taken X for the unit length, then we have taken for A half portion, then we have taken for 2A. So you can just mention here or maybe write somewhere, this is the length normally. Okay, so length is 2A and the height you have or the thickness you have H and one will become like width because this is a rectangle. So one will come width small w and this is the pressure here and you have the average pressure is P bar and the total load will be capital P or maybe you can take capital W or something. Fine.
Sir, which is the total width, sir?
Total load or total width?
Width, sir. In the third case, we are multiplying for.
This W, na small w.
Yes, sir. Yes, sir.
Yeah, small w is width. This is a rectangle. This is not like this is another side is there. Yeah,
Okay, sir.
another side is there. So one is the length, one is height, and another side is there width. Okay.
Okay, sir.
Okay, all clear. So all the three equations you can write because in the numerical you need all the equations. So we'll go for the numerical. One numerical just I prepare. Okay. So you can see here a rectangle. Can you see the question? I just hide the answer. Okay, I will show that.
Yes, sir. You can see
A rectangular block of height 40 mm, width 100 mm, and depth 30 mm. Okay, it is written height 40 mm, width 100 mm, and depth 30 mm is subjected to offset forging under sliding friction. When I'm writing height and width and depth, so you have to think which one will be length and which one will be height and which one will be the width. Okay, do not think that this is width. Okay, this will be probably a length because this is the longest one. Okay, so little confused. Do not think that this width will be like W. This will be the value of the A side, length side. Okay, is subjected to offset forging under sliding friction condition with a friction coefficient is 0.2. So you can write everything whatever is given. The material of the billet has flow stress expressed as Y equal to 300 into epsilon to the power 0.2. Calculate the forging load required at the height, a reduction of 30%, assuming plane strain compression.
Sir, 2A is 100, sir.
You just think. You just think, then I will tell.
Yes,
Okay.
sir. 2 and 100.
Yeah,
Sir.
2A will be 100. Okay. So read the question again. Maybe you can make maybe 2-3 minutes late, not an issue. But read the question twice because last time we have done only 2-3 numerical. But when you will go for the FAT, actually, you have all the module numerical you will find. So you will be confused. Okay. So read the question twice. Yeah. I'll show. Yeah. Given value you have already written, right?
Yes, sir.
So what is the A value is 50 mm, right?
Yes, sir.
Yes, sir.
Okay, H value. So you have to write because you need two things. One is initial and final, right? What we have done in I think module 1 probably, right? You know the volume module 1 probably we have done. You know the initially we have find out the volume, then volume will be same, then area AF, then A0, H0, HF. Okay, in this way if we'll do it will be clear. Do not write, sometimes we are writing H1, H2. So you'll be confused. So better to write HF somewhere or maybe HI, okay, or maybe H0. So you will understand clearly. H0 is, for example, initial one, or maybe HI. HF is final, F for final. So it will be easy for you. Do not confuse 1, 2. So you will be also confused there. So H0, for example, or maybe HI equal to 40 mm. This is height is given. Okay. Then depth means width. Okay. So depth equal to W equal to 30. These three are given. So you have to what you will find out initially. So you can write the equation like the average pressure. So from the average pressure, if you write the equation, then you can just put a tick mark because you are doing rough in the rough paper. So you can put a tick mark which value is given and which is not given. If this is not given, then you have to find out that one. In this way, you have to choose.
Yes, sir.
Amal, are you doing? Today you are silent.
Yes, sir, doing.
Yeah, yeah. Okay. Vishnu, is it okay?
Yes, sir. Okay, sir.
Okay. Nihar,
Yes, sir, I'm doing.
okay.
Excuse me, sir.
Yeah.
Could you please go to the questions?
One second. Yeah. Just you can try maybe for 2-3 minutes. You can try. Then I will show the explanation.
Okay, sir.
So in the equation, you have mu is given, right? 0.2.
Yes, sir.
H is given.
HF is given. Yes, sir.
HF is, you need HF, not H0. Okay, HF is given.
Yes, sir.
Yeah. So, and you have to remember that 30% is there. Height reduction of 30%.
Yes, sir.
Yeah.
Yeah.
Okay. So if 30% reduction, then you can find out HF.
Yes, sir.
Okay. So height is 40. So HF will be how much?
12.
No.
30% reduction. Oh, okay, sir.
Reduction. Na?
Yes, sir. 28, sir.
28. Okay. So HF is 28 and W is given 30. So in equation, what you need? In equation, mu is there, HF is there, then flow stress is also there. Okay. Flow stress is given 300 epsilon to the power 0.2. Okay. So that means you have to find out epsilon first. Right? Epsilon
Yes,
you need.
you can.
Yeah. So one thing epsilon you need, then AF you need. Okay. So epsilon you can find out. what is the equation of epsilon formula? Forgot?
Ln HF by H naught.
Yeah. ln H0 by HF, na? H0 by HF.
Yes, sir.
Yeah, so that one you can put. You have to remember all the equation. Okay, so if you will find out epsilon, you can get. So the moment you will get epsilon, then you can find out AF. How much is epsilon?
Minus 0.357.
No. What, minus 0.35 only. Why will come minus? Minus. 1 second, I will say. Not minus.
H naught by HF or HF by H naught, sir.
It's not by HF, na?
Then it's coming minus.
1 second. What I did, it was coming plus. No, it is coming 0.356.
Yes,
ln,
sir.
na?
Getting that.
Uh,
It is 0.35, sir.
yeah, 0.356, not minus. Why it will come minus? You have ln. So H0 is how much? 40 divided by 28. Yeah.
Yes, sir. I've taken HF as 44. Sorry, sir.
No. So that's why now you have to, write the initial, final, so it will be clear. Otherwise, you will confuse.
Okay, sir.
Okay, so epsilon is now clear. Other student, are you getting only 3.5 only you are doing?
Sir, I got like 0.45 or something. I made a mistake. I'll redo and tell sir.
Yeah. Okay. So just you can, you can follow the same path. Okay, maybe calculation this, maybe you are doing some mistake. So if this is epsilon 0.357, can you find out AF? Final length. Because you have H0, you have HF, you have A0, right? So can you find out AF?
Doing, sir.
Somebody is getting the value AF. The value is 71.43 millimeter. Yeah, up to now we have done it. Okay, so this equation have you wrote? I'm showing half of the answer.
Yes, sir, we are right.
Yeah.
Yes, sir.
So AF is 71.43.
Yes, sir.
Yesterday. I don't wrote somewhere because I have also done the same answer, I think. Yeah. Okay. So now in the equation, just you can check because you have to find out the average pressure first, average forcing pressure. So now mu you have, A you have, H you have. Only you have to find out Y bar. Okay. So that means the average flow stress. So can you find out average flow stress? So you have flow stress now. Y equal to 300 epsilon you got already 0.357 to the power 0.2. So flow stress you have now. So average flow stress can you get?
Yes, sir.
Yes, sir.
How much? Yeah, 203.4 unit you have to write because here if unit is not given, you can write any megapascal or something. Okay.
Yes, sir.
So now you got the average forging pressure you have. Can you find out average forging pressure?
Yes, sir.
How much? Yeah, so up to now we have done. So please, I'm requesting again, you have to practice at home. Otherwise, you cannot do it, very small. So I think you have done the area. Okay, it means the length you have done here, and then epsilon you have done here, and then Y bar also you have done here, right? And also the flow stress also you can done. Okay. So then you have to find out the average forging pressure. Do not be confused with that -1. Okay, so -1 will be whatever the value you have e to the power 2 mu a by h, and that value -1. Okay, not the
So those A and H are initial or final?
A will be which one you have to take?
Small A and small H.
Which value? This is final, na? Because you have to do the final you are making, not the initial one. Because you are converting from the initial to final, na? Right?
Yes, sir.
Okay, so that will be AF, and H is also HF. Because it is question you have to read. Calculate the forging load required at the height reduction of. So that means you have already reduced. For that reduction, what is the forging load you require?
So is it 353.68?
Yeah, fine. You can see here. I'm just showing. Okay. So now you can see here up to average flow stress you have done. Okay. So initially you have done AF, then you have done epsilon, then you have done YF bar. Okay. Three things you finished. Then average forging pressure with this help of this equation, all the data are available now. So you can find because why I put 199.41 because this first term is 199.41. Okay. The first term Y bar by 2 mu A by h. And the second part, e to the power 2 mu A by h minus 1, this term is 1.773. Okay, so directly I put here 353.59. Whatever maybe you are getting 68, it's fine. Okay, so now average forging pressure is fine. Okay. Yeah.
Okay.
So now last, what you will calculate, you have to calculate the forging load, that means total forging load. Okay, so now if you want to calculate total forging load, okay, so you have the average forging pressure. So you can just directly multiply by 2A. So if you directly multiply by 2A, you will get this value. But if you will get average forging load, okay, average forging load. So here they have multiplied only initial small a, okay, the small a. But if you will get total forging load 2A, you know, whatever the equation I have mentioned here, this equation. P equal to P bar 2A into W. Okay, sir, P bar you already got 2A value, you know, W you know, so you will find out PA. Okay, but if this is asking average load, then you can consider only A instead of 2A, because half portion you are considering average. If total, then 2A, right? So I have just done in the 2A, average forging load equal to whatever the forging pressure you have P, okay, and whatever the A value you have got here, AF equal to 71.43 into the width. Width is how much? 30. So you will get around 757.7. Okay. But if you want to total forging load, instead of this the 71.43, okay, you have to multiply 2A. That means 2 into 71.43. Okay, so you will get the total value here now 757 into 2. You will get total value, whatever you will get. Okay.
Yes, sir.
Fine.
Yes, sir.
Okay.
Sir, but in this case, we take 2A is equal to 100, sir.
2A equal to 100, na? 2A equal to 100. So A equal to 50. Initially you have converted, na? A0 equal to 50. This is width, this is length. The depth we are talking about 30 W. Okay, so I just made confuse here to you. Width means the length, because this is the bigger side. Okay, because this is a plate is coming, so this is bigger side. Actually, if in the normal language we should give length actually, but I want to confuse you so that you will understand. You know, the bigger, because sometimes in the book actually they have mentioned, you know, I'm at least writing clearly height this one, width this one, and depth, but they are asking 40 into 100 into 30. So in that case, it is very difficult to understand.
Yes, sir.
Okay, maybe in the exam I will give you 40 mm into 100 mm into 30 mm. Okay, so you have to understand, if length is clear, then also you will understand the width is normally small, height is bigger, because from height you are reducing that one from 40 to 28. Okay.
Yes, sir.
Okay, and if you do, if it is asking average forging load, if directly also you can make it 2A multiply, so you will find this total. If this is not asking average forging load, not necessary to do also. One step you can remove. Okay.
Okay.
Okay, fine. Okay, so we have completed today the module 3. So in the next class, we will start module 4, the rolling.